So what if you're given this question 2017 RI, you're given the expression, you're not supposed to use GC lah. Okay, so you're told that the root is 1 plus 3i and the a and b are real. Okay, now first thing is this, what you need to understand is for every one complex root, right, you can solve for two unknowns in a complex equation. One complex root can solve for two unknowns. Remember that, two real unknowns. Let me explain. If a and b are real, one complex root can solve for two real unknowns, okay, for any given equation. So this one, if you have two real unknowns here, what you need to do is you just sub 1 plus 3i into the equation, okay? So that is the way to go about it lah. So I'm gonna just substitute it in and hope for the best, okay? This part here, we got, you asked you to show, right? So this is 1 plus 3i to the power of 4 plus 2, 1 plus 3i. You're not supposed to use calculator. So what you're going to do is you just slowly expand. You could use calculator to check your answer, that's for sure. Okay. If I were you, I would just slowly expand. So what I'll do is I'll expand the square first. So this would be, I know that 1 plus, so this one would be 2 square, right? So it's 1 plus 3i square times 1 plus 3i square. Then I'll just expand like that. Square. And this will be, okay, I just keep it as it is first. Okay. So you just key in calculator for 1 plus 3i square and see what do you get. Okay. So you just act like you expand properly lah. So this one is 1 plus 3i square, 1 plus 6i plus 9 minus 9. Okay, so this is minus 8 plus 6i lah. So this case here will be minus 8 plus 6i, minus 8 plus 6i plus 2, 1 plus 3i, minus 8 plus 6i plus a, minus 8 plus 6i plus b, 1 plus 3i. Okay, then just expand this lah. This one here expand as well. This one expand as well. Just use calculator to check answer. I'll just use calculator and check. You know how to use calculator and check, right? So those of you may not know, so I'll just demonstrate how to use your. So 1 plus 3, if you do not know, you can use calculator and check. So 1 plus 3i, that's what you do. Go to mode, just make sure your mode is in a plus bi. Then what you need is minus 8 is what? 1 plus 3i. 3i, second I is here above decimal, square, minus 8 plus 6i. Then you want to square this to the power of 2. My goodness, I should bracket it. Okay. Check. So it's 28 minus, so you just, yeah. Just write down like that lah. Just write down that. Minus 8 plus 6i square is equals to 64. 28 minus 96i. Okay. You just act as if like you never use calculator, but you actually did. So 64. Yeah. Okay. There you go. Then for this one, same thing. Just expand. Minus 8. Minus 8 plus 6i 24i. Okay. Thinking calculator, see what it gets you. 1 plus 3i. Oh, very tedious. Minus 8. Negative 26 minus 18. Okay, there you go. So once you're done already, then you just key in calculator for this whole thing here and check what is this. Okay, this one is okay lah. From here onwards, I think calculator should be fine already. Okay, there you go. Yeah, actually, this method, root method, not sure. Let me see. You're not supposed to use calculator. So you can't use a calculator to even find the root. Okay. Yes, you can use the long division method. You can use the coefficient method. Yes, you can. You can. So this is method 1. Later I'll go through that one. Okay. So method 1 is substitute the root. You can do the other way. I actually prefer the other way also. Okay. So once this is done, just key in calculator and check. So what do you need? This one. Plus 2 minus 24 minus 13i as well. 132i. Then you have minus 8. B imaginary parts. Compare the real and imaginary parts. Minus 24 plus minus 8i. Minus 132. So compare both. Oh crap. Without using calculator. Ayo. So tricky. Ayo, not the correct answer. Let me check. This part, once you're done, you can just solve for the other roots. Okay. You. I don't really like this method because it doesn't solve for the root at once also. Okay, so what I would prefer is, so this one you just continue. So you solve for A and B already, then you just solve for the other roots of the equation by doing long division. So what I like to do is, I actually like to just use this method here because you can straight away solve for the root as well. Okay, so this is what I'll do. I'll use the this z square minus sum of roots plus product of roots. the quadratic factor and compare the coefficient. Okay, so the quadratic factor basically is comparing coefficients. This is faster. So quadratic factor is actually just can you remember in secondary school you learned sum of roots, right? Sum of roots, since all are real, so since coefficients are real, you have 1 minus 3i is also a root. By conjugate root theorem, you want to write that down, you can write it down. So the quadratic factor quadratic factor would be z square sum of roots 1 minus 3i product of roots then so quadratic factor will be z square minus 2 z plus 10. Okay, if you don't like this, you can just expand it lah. You know, just use this value here and expand also can. Okay, but those of you who did complex with me, you know that this is not the first time I do this. So what we do is you compare it with Z4, and that's faster. So much faster. Z4 plus 2z cubed plus az square plus bz equals to 50 will be equals to let's just use a z square plus bz plus c lah. Then you just multiply them because this is power of 4, so quadratic times quadratic will give power of 4. Yep. I think this is faster comparing Z4 A equals to 1. You start from the highest power to the lowest power. Usually that's the easiest. Then the constant, comparing the constant with 50 equals to C times 10. C will be equals to 5. Okay. And then you start with Z. Z will be equals to B on the left hand side. And you will have got 10B minus 2A. Minus 2A. Maybe on the hindsight should have used z cube. Z cube here is 2. So you have got z cube will be, I used the wrong one, sorry. Z cube will be minus 2a minus 2 1 plus b z cube. So this will give it a lah, straight 1 2 4, so b is equals to 4. Comparing z would means b z, so it's 10b minus 2c. Anything else? Z, yeah, that's all. 10b. So I do not have, I have c, I have b, so this is 40 minus 10. 30. Is that 30? Yeah, you see, so fast. Yep. Then after that, comparing z square. You have got a equals to 10a minus 2b, which is actually 10 minus 8, which is 2. Wait, there's one more. Z squared plus c. Yeah, c, do we have c? 5. 10 minus 8 plus 5, 7. Yeah, great. I think comparing is faster. So once you're done already, you could actually find the other root, which is this one here. So the other quadratic factor, other factor would be z square plus 4z plus 5. So this is okay. So this will be z equals to minus 4 plus minus b square minus 4ac over 2 lah. So 16 minus 20 will be minus 4. So this is plus minus 2i. 2 minus 2 plus minus I. Hence other root. Oh, the other root is what? 1 minus 3i. Okay. I think I will prefer the comparing coefficient. But if you prefer otherwise, you go. Yeah, I just write the two methods down so you can compare and contrast. You must understand that the comparing one will straight away solve as well. So it's easier lah. The substitution one will not solve it straight away. So it's very annoying actually. Especially when they say no use, unused calculator.